Whenever an atom of an element contains 8 electrons in the valence shell, this is the most stable arrangement for any atom except helium, which has only 2 electrons. This is known as a duplet structure. This is the most stable structure for helium, except that all the elements which have 8 electrons in the valence shell, that is the most stable arrangement for any element. This arrangement is known as octet. This is the most stable arrangement shown by the elements which are known as noble gases. So all the noble gases except helium, helium shows a duplet structure, all the noble gases have an octet structure. And that is why noble gases are also known as inert gases. It is because they have the most stable structure, so they do not react with any other substance. They do not undergo any chemical reaction. That is why they are also known as inert gases. So whenever an element, it has 8 electrons in the valence shell, that is the most stable arrangement for any element. So all the elements try to achieve this noble gas configuration. Let's see how they do that. So whenever an element has 1, 2 or 3 valence electrons, in order to satisfy the octet, it can lose the electrons. So when the elements lose 1, 2 or 3 electrons, such elements are known as metals. Metals are those elements which can lose electrons. Similarly, whenever there are 5, 6 or 7 valence electrons, in order to complete the octet, they can lose these 5, 6 or 7 electrons. But it is not easy to lose these. Instead, they gain 1, 2 or 3 electrons. So such elements which gain electrons to complete the octet are known as nonmetals. And when the elements have 4 valence electrons, it is not easy to lose or gain 4 electrons. Instead, it shares 4 electrons with some other atom. Such elements having 4 valence electrons are known as metalloids. So all the elements try to achieve the nearest noble gas configuration. So if you have sodium, it has 11 electrons. So it has the electronic configuration 2, 8, 1. So in order to complete the octet, it has to lose 1 electron. So now it has to lose 1 electron. So it becomes Na plus. This is because if it loses 1 electron, now it has 1 electron less. So it becomes a positive ion having the electronic configuration 2, 8. Now the valence shell has 8 electrons, so it is stable. So sodium loses 1 electron to have a stable electronic configuration. So sodium is a metal. Chlorine, it has an electronic configuration 287. Now in order to complete the octet, it gains 1 electron. It needs 8 electrons in the valence shell. So in order to complete the octet, it gains 1 electron. So when it gains 1 electron, it becomes Cl minus. As there is 1 extra electron now, it becomes a negative ion having the electronic configuration 288. So now there are 8 electrons in the valence shell, so it is stable. So chlorine gains 1 electron to satisfy the octet, hence chlorine is a non-metal. What happens when an element has 4 valence electrons? So now carbon has 4 valence electrons. It is not easy for carbon to lose or gain 4 electrons. So it shares 4 electrons with 4 hydrogen atoms. Let's see how it does that. So now each hydrogen atom shares 1 electron each with the carbon atom. In doing so, each hydrogen has 2 electrons. That is, each hydrogen atom has a duplet structure, and carbon has 1, 2, 3, 4, 5, 6, 7, 8. So now carbon has 8 electrons, so even it satisfies the octet rule. So both carbon and all the hydrogen atoms are now stable. So in case of carbon or elements having 4 valence electrons, they become stable by sharing electrons. Such elements are known as metalloids. Valency is defined as the number of electrons gained, lost or shared so as to make the octet of electrons in the outermost shell. We know each element tends to have an electronic configuration of the nearest noble gas. Noble gases have 8 electrons in the valence shell. So in order to gain 8 electrons in the valence shell, the number of electrons lost, gained or shared by the atoms is known as the valency. So let's see, when an element has 1 valence electron, it can lose 1 valence electron. So it has a valency plus 1, or we can simply write 1. When there are 2 valence electrons, it can lose 2 electrons to complete the octet. So the valency becomes plus 2 or simply 2. Similarly for 3, we get plus 3 or simply 3. Now when there are 5, 6 or 7 valence electrons. Now when an element has 5 valence electrons, in order to complete the octet, it gains 3 electrons. So the valency becomes minus 3. As now it has 3 extra electrons, so the valency becomes minus 3, or we can simply write it as 3. Similarly for 6 valence electrons, the valency becomes minus 2 or simply 2, and for 7 valence electrons, it becomes minus 1 or simply 1. When there are 4 valence electrons, these elements are metalloids. They share 4 electrons. Since they share 4 electrons, so the valency is 4. So these are the valencies for the elements having valence electrons from 1 to 7. An element X loses 2 electrons to complete its octet. So is it a metal, non-metal, metalloid or a noble gas? We know when an element loses electrons, it is a metal. In this case, X loses 2 electrons to complete its octet, so X is a metal. Now, some elements, they lose electrons from both the outermost shell. The outermost shell is also known as ultimate shell or valence shell, and the shell before the outermost shell is known as penultimate shell. Some elements, some exceptional elements, they can lose electrons from both the ultimate shell and the penultimate shell. When they do that, they can exhibit more than one valency, and so they are said to exhibit variable valency. So far we have studied that elements lose electrons only from the ultimate shell. So how they lose electrons from the penultimate shell also is beyond the scope of this lecture. But for now, we need to know that some elements, some special elements, they lose electrons from both the ultimate shell and the penultimate shell. So when they do that, they show more than one valency, that is, they exhibit variable valency. Let's see some examples. Copper. Copper shows 2 valencies, that is plus 1 valency and plus 2 valency. The plus 1 valency can also be shown in the Roman letters. Similarly, we can show the plus 2 valency in Roman letters. So now copper shows 2 valencies. Now out of these two, which one would be called copper ion? Is this copper ion or is this copper ion? You know, it's not simple to answer this. Therefore, for elements which show variable valency, we use a system of nomenclature. That is, the element with the lower valency gets the suffix OUS, and the element with the higher valency gets the suffix IC. So now Cu plus 1 is cuprous and Cu plus 2 is cupric. Keep in mind, whenever an element exhibits variable valency, we give different names to the two ions being formed. The element with the lower valency gets the suffix OUS, and the element with the higher valency gets the suffix IC. Out of Ag plus 1 and Ag plus 2, which ion is named argentic? So the Latin name of silver is argentum. So now we have to find out, is this argentic or is this argentic? We know for elements showing variable valency, when it shows a lower valency, so plus 1 is a lower valency, this gets a suffix OUS, and Ag plus 2, this is showing a higher valency, so this gets the suffix IC. So in this case, the ion which is named argentic is Ag plus 2. Similarly, there are other examples like mercury. Mercury also shows two valencies, Hg plus 1 and Hg plus 2. So the lower valency, that name gets the suffix OUS, and the higher valency, it gets the name IC. Similarly, iron, it gets its name from the Latin name ferrum. So it shows plus 2 and plus 3 valency. Plus 2 is lower, so it becomes ferrous. Plus 3 is higher, so it becomes ferric. Similarly, tin, it gets its name from the Latin name stannum. So it becomes, for plus 2, stannous, and for plus 4, it becomes stannic. So whenever an element shows variable valency, the ion with the lower valency gets the suffix OUS, and the ion with the higher valency gets the suffix IC. Don't worry, once you start using the variable valencies, you'll become comfortable with the elements which show these valencies.